Here we have the settings for our experiment. We have here the three PQSDR platforms connected to the Ethernet switch, and the Ethernet switch is also connected to these two computers, one laptop and one PC. One of the PQSDR right now is used as a primary user, emulating the primary user, transmitting the pattern in the spectrum. And the other one is the cognitive receiver, which is the one that performs the spectrum sensing. So going to the computer, I'm going to launch the executable for spectrum sensing. So we select the folder where we are going to save our data. This is the window. Here we have all the boxes for giving the configuration for the spectrum sensing. Here we put the sensing time, we can see, to 6.5. Then the probability of false alarm, 0.01. We can change. We can put any value, but we put 0.01. The number of repetitions L is 20. Also the subband false alarm probability, and the number of frames for the total experiment. Now, okay, I put 500, which is enough to make the video. And in this moment we launch from MATLAB a script to make the transmission, and we will see here in the screen the pattern that we are transmitting right now. We see that we don't have anything outside the band of from -7 MHz to 10 MHz, and from +7 MHz to +10 MHz because of the baseband filter. So we can see here the window and how we are able to detect the subbands. Here, and we're making the histogram in the left, that is for edge detection, and on right, that is for subband. And we see how the histogram is made, and we check that the pattern is the same that we transmit. We see in the upper left corner the edge detection test statistic, and in the upper right the subband. And we are building now the histogram. We see the values. The detection going to 1, 0.1, and in average it will become close to the desired probability of false alarm for the non-transmitted bands. We see here also, and this pattern will change in time, and we will see another window that we change the pattern in frequency. So we see how now. So all the histogram must change in time, and we will see how the detection is changed. We see that, okay, this is the pattern that we are transmitting right now. I'll minimize it, and we see how the histogram is going to change. We should only have two edges inside the band, because we have some other edges in the corner of the baseband filter. And we see how the histogram is going lower and lower, and we see the limit up to 10 MHz, which are corrupted by the baseband filter. But here it's interesting to see the edges of the subband, and with the histograms, and here the result for the spectrum sensing. We see that in average, because we don't have enough measurement to have a very accurate probability of false alarm, but you see that in more or less is going to the desired value, or 0.01. For the longest measurement that we have taken, it finally go to the desired value. Maybe here we go a little bit above and sometimes a little bit below, but in average for a long time we get an accurate probability of false alarm. Okay, it is like that. Thank you very much.